Welcome to the deep dive. Today we're tackling something really quite fascinating. It's about how AI agents, these different AI minds, are going to actually communicate and work together.
Yeah, it's a huge area right now. You shared an article that lays out three key protocols emerging: MCP, ACP, and A2A. Sounds like alphabet soup, but they're important.
Exactly.
Yeah.
And our goal here is to, break these down for you, give you a really clear understanding what they are, how they work, why they matter for where AI is going.
Without getting totally lost in the technical jargon.
Right. Think of it as your shortcut to getting up to speed on this. A few aha moments, hopefully.
Definitely. So we'll look at each one. First up is the Model Context Protocol, MCP. That's about giving an individual AI the context it needs.
Okay.
Then we'll shift to the Agent Communication Protocol, ACP. That's more about local coordination between agents.
Like on the same device or network?
Precisely. And finally, the Agent-to-Agent Protocol, A2A. That one's aiming for broader collaboration across different systems, different places.
Got it. So by the end, we should see how these different pieces will hopefully fit together.
Yeah, and what kind of cool possibilities they open up.
Okay, let's dive into that first one then. MCP, Model Context Protocol. This one comes from Anthropic, you said.
That's right, Anthropic.
And the core idea, as I'm getting it, is making sure these big language models, the LMs, have the right info at the right time. Context, basically.
That's a perfect way to start thinking about it. What's really neat about MCP is how it injects this relevant, often real-time context in a really structured manner.
So instead of just stuffing more and more static knowledge into the model itself.
Exactly. MCP offers a way for the model to reach out and grab external resources. Think files, databases, maybe live API results. It's about giving the AI temporary access when it needs it.
Okay. The article mentioned three main ways it does this. The first one was contextual data injection.
Right. That's pretty much what it sounds like. It's a standardized way to pull in that outside data.
From, anywhere. A file, a database.
Yeah, or an API call. It brings that data right into the model's, let's say, working memory, or even directly into the prompt it's processing.
And that helps keep the LLM itself leaner.
Leaner, more efficient, exactly. It doesn't have to store the entire world's constantly changing information internally. And that standardized interface bit is key. It means different tools and systems can talk to the AI using the same language, essentially.
Okay, that makes sense. Then number two was function routing and invocation. That sounds more active, like the AI can do stuff.
Yes. This is where it gets interesting. It's not just about knowing things, it's about acting. MCP lets the model call upon external tools that have been registered.
The article used examples like search customer data or generate report.
Perfect examples. So the AI isn't hardwired with the code to search customer data. Instead, ACP lets it say, hey, I need that search customer data tool right now, and then it can invoke it.
So it's like giving the AI a dynamic toolkit.
A dynamic toolkit, exactly. It can grab the right tool from the workbench for the job at hand, massively expands what it can potentially do without bloating the core model.
And the third part was prompt orchestration. This sounds like it's about building smarter prompts.
You got it. Instead of just throwing a wall of text or data at the model, MCP helps assemble just the right pieces of context for whatever the current task is.
On the fly.
On the fly. Based on the situation, maybe the user session, whatever makes sense, it leads to much more focused prompts.
Which should mean better, more relevant answers from the AI, right?
Absolutely.
Right.
Better outputs, potentially faster processing, maybe even cheaper API calls because the prompts are more concise.
Now, how does it actually work? The article mentioned it runs over standard web stuff. HTTP, HTTPS, uses JSON.
Yeah, it uses those familiar building blocks, HTTP or HTTPS for communication, and JSON to describe the capabilities, the tools the AI can use.
And it's model agnostic, meaning it doesn't care which LLM you're using.
Correct. As long as the LLM has a compatible runtime environment, it can work with an MCP server. That's a big, plus avoids vendor lock-in.
Plus, it works with enterprise security standards. OAuth 2, MTLS. That sounds important for businesses.
Crucial. It means you can actually use this securely inside a company, connecting LLMs to sensitive internal data or systems.
The use cases really drive it home. You could hook an LLM up to internal company APIs, right? Securely.
For sure. Either for read-only access or even interactive tasks, or imagine equipping those enterprise AI agents with live context from Salesforce, SAP, things like that.
Wow, okay. A customer service bot pulling real-time data from Salesforce. That could be a game changer.
Totally. Or an internal help desk AI securely checking the company knowledge base. And that dynamic prompt building based on user activity that allows for really personalized, efficient AI workflows.
Okay, I think I'm going to handle an MCP. It's about giving the AI the right context and tools. Now let's switch it up. ACP Agent Communication Protocol. This one's from BAI and IBM.
That's right, BAI and IBM.
And this feels different. The focus seems much more local, more immediate.
You nailed the key difference right there. MCP gives context to one model. ACP is designed for multiple AI agents to talk and coordinate directly with each other, but within a local space.
Like on the edge, or robotics.
Exactly. Think edge devices, robots, maybe even just different AI processes running on the same machine or local network. The article stresses it's local first, real time, very low overhead.
So not really aimed at cloud communication then.
Generally, no. It contrasts with cloud-centric protocols like A2A, which we'll get to, and also with MCP's context focus. ACP is about peer-to-peer chatter nearby.
How does that work if it's not using the cloud? How do they find each other and talk?
It's typically decentralized. An agent basically broadcasts, hey, I'm here, this is what I can do, and this is my current status to other agents in the local environment.
And they communicate how?
Usually through event-driven messages. Maybe over a shared local message bus or something called inter-process communication, IPC. Sometimes there's an optional controller piece for managing things or enforcing rules, but the core is decentralized.
The article mentioned agents are often lightweight, stateless services. Why is that important here?
Stateless means they don't really hold on to past conversation history internally. Lightweight means they're simple and don't consume many resources. In a local real-time setting, this makes them super fast and responsive.
Easy to spin up or down as needed, I guess.
Exactly. And they communicate efficiently over that shared local channel without the lag of setting up complex connections each time.
The implementation details really point to those low-latency uses. Robotics, offline AI systems. It makes sense you'd want instant communication there.
Totally. You can't have a robot arm waiting for a round trip to the cloud to decide its next move. ACP can run over different fast local methods, gRPC, 0MQ, even custom buses.
And that local sovereignty idea, no cloud dependency, that's big for privacy or places with spotty internet.
Huge. If you need it to work offline or you can't send data out, ACP is designed for that. Plus, it supports defining agent capabilities, so tasks can get routed automatically to the agent best suited for the job locally.
The use cases are pretty clear then. Factory robots coordinating.
Yep. Or multiple sensors and AI components in a smart home working together without the cloud.
Yeah.
Or maybe a swarm of drones.
Right. It enables those autonomous local systems that don't need a constant tether to a big server somewhere.
Precisely. It's about resilience, speed, and composing complex local behaviors from simpler agents.
Okay, clear. MCP for context to one AI, ACP for local chat between AIs. Now the third one, A2A, agent-to-agent protocol. This one's from Google.
Yes, Google's behind this one.
And this sounds like it's going for the big picture,
Yeah.
like connecting AIs everywhere.
That's definitely the ambition. A2A is about enabling communication, collaboration, even delegation of tasks between AI agents that could be running on totally different platforms.
Different clouds.
Yeah.
Different companies even.
Potentially, yes. It's focused on that horizontal interoperability across systems, mainly over the web. So it contrasts with ACP's local focus and MCP's tool integration focus.
So if ACP is agents chatting on a local network, A2A is like agents anywhere on the internet finding and talking to each other. Is that fair?
That's a pretty good analogy, yeah. A2A treats AI agents like interoperable web services. They can discover and communicate using standard internet tech.
The key seems to be this thing called an agent card, like a digital business card for an AI.
Exactly. It's a JSON file, basically a profile. It tells other agents who I am, what I can do, my capabilities, where you can reach me, my endpoints, and how you need to authenticate to talk to me.
So Agent A can look at Agent B's card, see it has a skill it needs, and figure out how to connect and make a request.
That's the core mechanism. Discover, then communicate.
And how does that communication actually happen? What's the protocol?
A2A primarily uses JSON RPC 2.0 running over HTTPS. JSON RPC is just a standard way for programs to call functions on other programs over a network and get structured results back. HTTPS keeps it secure.
The article broke down some core components. The agent cards, obviously. A client-server interface, meaning an agent can both ask for things and offer services itself.
Right. Agents can be clients, servers, or both. Very flexible, allows for dynamic routing of tasks.
And it supports more than just simple messages. It mentioned complex data, streaming.
Yeah, handling multi-part tasks, streaming data back and forth using things like server-sent events, SSE, and exchanging persistent artifacts like files. That's all crucial for more complex ongoing collaborations.
I also saw something about user experience negotiation. What's that about?
Ah, that's quite clever. It means agents might be able to adjust how they format their messages or the level of detail based on what they know about the receiving agent's capabilities, makes the whole exchange smoother.
Makes sense. Now, security must be a massive concern if agents are talking across the internet like this.
Absolutely critical. A2A relies on standard, well-understood web security mechanisms. OAuth 2.0 for authorization, API keys, things developers are already familiar with.
And capability scoped endpoints. Does that mean an agent only exposes the functions needed for a specific interaction?
Exactly. It limits the attack surface. There's also this opaque mode where an agent can advertise its services without revealing all the internal details of how it works. Good for proprietary systems.
And like MCP, it's model agnostic and uses web tech. The use cases seem broad, linking agent ecosystems across platforms.
Yeah, imagine agents from different vendors, maybe one running in Google Cloud, another in AWS, seamlessly working together.
Or orchestrating tasks across different specialized agents in a large company like a CRM agent, talking to an HR agent, talking to an IT support agent.
Precisely. That level of interoperability is the goal. It could unlock really powerful distributed AI workflows.
Okay, wow. So we have MCP for context and tools, ACP for fast local talk, and A2A for broad web-based collaboration. The big question then, how do they all fit together? Are they competitors or complementary?
That is the million-dollar question, isn't it? The article makes a strong case that particularly A2A and MCP are actually very complementary.
How so?
Well, think about it. MCP connects an AI to data and tools, right? The outside world, essentially.
Right. Databases, APIs.
Whereas A2A connects an AI to other AIs.
Ah, okay, I see that. One talks to resources, the other talks to peers.
Exactly. The article sums it up nicely. MCP bridges AI to tools. A2A bridges AI to AI.
So you could easily have an AI using A2A to ask another AI for help, and maybe that second AI uses MCP to grab the data it needs to answer.
Precisely. They solve different but related problems in building complex AI systems.
Okay, that makes sense. What about ACP then? Where does that slot in? It's clearly different.
It is different. ACP isn't really trying to compete head-on with A2A for that broad internet communication. Its niche is those specific situations we talked about where you need very low latency, high reliability, local-only communication.
The robotics, the edge device.
Exactly, or scenarios with strict data privacy where nothing can leave the local network. In those controlled local environments, ECP might actually be preferable to A2A because it avoids the overhead of web protocols. It's potentially faster and more direct.
So it's choosing the right tool for the job. Use A2A for broad interop, but maybe ACP for things happening in the same room or same machine.
That's a great way to put it. ACP fills that specific but important niche for local, efficient coordination.
Looking ahead, the article floated a couple of possibilities. Convergence, where these somehow merge or work seamlessly together, or fragmentation, where maybe we get competing standards.
Yeah, and it's still very early days, as the article points out. We're just seeing these protocols emerge and gain traction.
Ideally, you'd want convergence, right?
Yeah.
A world where A2A, MCP, ACP can all play nicely together.
That would certainly make life easier for developers building these systems. A unified landscape where an agent can use A2A to talk across the net, MCP to get data, and maybe ACP for local subtasks.
But the risk is fragmentation. Different companies pushing their own incompatible versions.
That's always a risk with new standards, kind of like the early format wars in other tech areas. We could end up with silos.
The article mentioned open source tools or middleware as a possible middle path,
Yeah.
like translators between protocols.
Right. Abstracting away the differences. That could provide a layer of consistency for developers, even if the underlying protocols remain distinct or evolve separately. It's definitely something to watch.
So we're kind of at a crossroads. The choices being made now about adopting and developing these standards could really shape how AI collaboration evolves.
Absolutely. It's a foundational layer. Whether we get a truly interconnected AI web or more isolated systems could depend heavily on how these protocols develop and get adopted.
Well, this has been incredibly helpful. Seriously, a great deep dive into MCP, ACP, and A2A.
Glad we could break it down.
So just to recap quickly for everyone listening, MCP gives AI the context and tools it needs. ACP lets local AIs chat efficiently. And A2A aims for that big picture collaboration across different systems online.
That's a solid summary. They're really the building blocks for the next wave of smarter, more cooperative AI.
Understanding them, even at this level, feels pretty crucial now if you're trying to follow where AI is headed.
I agree. Knowing the difference in how they might interact gives you a much better lens for interpreting new developments.
So here's something to think about as we wrap up. How might this play out for you? Consider whether these protocols converging smoothly, or maybe fragmenting into different camps, could change how your future AI assistants or tools interact. Will they talk seamlessly behind the scenes, or will they be stuck in their own little worlds? Definitely something to keep an eye on.